Hello everyone. Today I will be presenting our study Quantitative Confounder Analysis of Electrocardiogram Signals in Cardiac MRI at 1.5T, 3T and 7T, assessing standardized electrode positions and sequence types towards quality assurance. ECG gating is essential for cardiac MRI image acquisition. Inside the MRI, however, the ECG signals which are used to synchronize the heart motion with image acquisition may be confounded. This may occur, for example, due to the magnetic field strength with a magnetohydrodynamic effect, due to electrode placement, or also due to the sequences themselves with gradient interference. Increased distortions may lead to insufficient gating, which can affect image quality, as seen on the left. Increased distortions occur especially at ultra-high field strengths, therefore posing a significant challenge to ultra-high field imaging. Therefore, the aim of this study was to quantify the influence of several confounders on ECG signal quality, namely the field strength, 1.5T, 3T and 7T, 4 standardized electrode positions, and standardized sequence types. In our study, we looked at Cine sequences with and without breath hold and 4D flow sequences to assess their impact on the ECG signal quality and the cardiac MRI image quality. We enrolled 16 healthy volunteers after written informed consent. ECG signals were recorded at 1.5T, 3T and 7T scanners with 4 electrode positions, which can be seen on the right. The electrode positions are based on vendor-recommended electrode positions, position 1 and 2, or alternative positions based on the literature, position 3 and 4. These alternative positions are defined based on recommendations for ultra-high field imaging in particular, and a detailed description can be found in the main manuscript. Prior to obtaining the ECG signals inside the scanner, we performed so-called baseline scans without any confounders present. The volunteer was placed outside of the scanner bore, and the ECG signal was recorded to later serve as a reference for the confounded test measurements. For the test measurements, we recorded ECG signals while playing out short-axis Cine sequences with and without breath hold and 4D flow sequences. This was repeated for all the 4 positions and at all 3 scanners. In addition, image quality was rated by 3 expert readers on a 4-point Likert scale. To compare confounded test ECG measurements with the baseline measurements obtained outside the scanner, we performed so-called QRS-feature correlation. The method averages all windows around manually annotated QRS complexes to form a single QRS feature representative of the measurement. This was done for the baseline measurement as well as the test measurement. The 2 QRS features were then correlated to serve as a measure to quantify ECG signal distortion due to the confounders present in the test measurement. We used linear mixed models to account for repeated measurements within the volunteers. Details are provided in the main manuscript. To test for significant differences for each of the confounders, we used type 3 test of fixed effects in a global analysis. In addition, a pairwise subcomparison between subgroups was performed. Details can be found in the main manuscript. We observed a significant difference between field strengths, namely lower similarity values were observed at 7 Tesla, but also at 3 Tesla compared to 1.5 Tesla. The electrode positions recommended by the vendor, namely position 1 and 2, provided similar ECG signal quality, and also electrode positions recommended in literature provided similar ECG signal quality. However, ECG signal quality was significantly different between vendor-recommended positions and alternative positions defined in literature. We observed significant differences between the sequences only between breath hold acquisitions and non-breath hold acquisitions. This difference was more pronounced in the subgroup analysis at 7 Tesla. For details, refer to the main manuscript. Image quality decreased with increasing field strength, as can be seen on the right. The 4 positions showed similar image quality when compared at a single field strength. We observed a significant difference between breath hold image acquisitions and non-breath hold image acquisitions. To conclude, increasing field strength led to a decrease in ECG signal quality. Vendor-recommended and alternative electrode positions performed similarly at 1.5 Tesla. At 3T and 7T, vendor-recommended positions provided less distortion than alternative positions and should therefore be used preferably. The standardized sequences showed no significant differences at clinical field strengths of 1.5T and 3T. At 7T, however, Short-axis non-breathal sinus sequences showed slightly lower ECG signal distortion than short-axis breathal sinus sequences, but lower subjective image quality. With this, I would like to thank my team for their continued support with the project, and also JMRI for publishing our work. Especially I would like to thank the anonymous reviewers for their valuable comments, and also the editors-in-chief, Mark Schweitzer and Rezan Nezafat. Thank you very much.